So, law of sines. Basically, what this is going to allow us to do, it's going to allow us to find side lengths and angle measures of not right triangles. Right? So everything we've done so far, we've dealt with right triangles. But now we're going to learn how to apply some of the stuff we know to triangles that don't have 90-degree angles in them. Why not?
Because right triangles are so nice.
Yeah, but these aren't bad either. So, let's say we have that looks like a right triangle. I'm already off to a good start. That's crap. I get so used to drawing. That's an equilateral.
It's a burrito.
I get so used to drawing right triangles. There, that's better.
I'm so confused. What are you trying to not draw?
I'm trying to not draw a right triangle, and I was trying to not draw an equilateral triangle. Just trying to draw a triangle.
Can you draw?
It's fine.
You can draw a triangle without it being. My brains are working. Yeah, mine still ended up being right. So
That's
I'm gonna say it's not right.
That's fine. So remember we have angles A, B, and C. And then remember that we name the sides of our triangle. So like side A is a lowercase a and it's opposite of angle A. C is opposite of C, and B is opposite of B.
Beans!
What?
Does it matter which one's A, B, and C?
No, as long as you have side A across from angle A, B across from B, C across from C. It doesn't matter where they are.
Yeah.
I forgot when we did this whole stuff. I hated it.
Well.
Will we be using the Pythagorean
This was
theorem?
No, Pythagorean theorem only works for right triangles.
This was the first time I went on quarantine from soccer, and I didn't know what the heck was happening.
Yeah, well, it's all right. I got you now. You're here. That's what matters. So, we're going to use the law of sines. So basically what the law of sines allows us to do is it allows us to make a ratio of any two sides and the sine of two angles.
Can you write that?
I'm just trying to explain while I go. So basically it comes like this. So we can have A over sine of A is equal to B over sine of B. Can also be equal to C over sine of capital C. So basically what we're going to do is we're going to use any two parts of this. We don't have to use all three at once. Any two parts to solve for one like missing piece. So like let's say I knew what angle A was, I knew what angle C was, and I knew what side C was. So then I would use this and this to set up an equation with one variable left in it to solve.
Wait, hold on, what?
I'm going to do an example and show you. That's going to be way easier. I'm just also trying to talk through what we're doing. So,
Does that mean they all equal the same? Wait, equal each other?
the ratios do, yes.
Okay.
Like,
So if one of them's 3 over 2, then they're all going to be 3 over 2.
right.
Would you let me change that?
Yes, not right now, but yes, I need to change it. Okay, so, for example, let's say that we know angle A is equal to 40 degrees. And let's say B is 65. And let's say that side A is equal to 6. Right, so that's the information we're given.
Pythagorean theorem.
No, we can't use that.
Oh wait, can
Not
B?
a right angle.
It's not a right triangle.
Can B equal 75? C?
Yes. So, we know that there's 180 degrees in a triangle. Right? So we can do 180 minus 40 minus 65 to get that C is 75 degrees. Right? So,
Are your videos?
mm-hmm. Yep. Thanks. All right, so now let's try, we need to find side B and side C. So let's find side B first. So we know we have both parts for side A, right? For A, we have angle A and side A. So we're going to use this part of it to start with. So side A is 6 and angle A is 40. So that's going to be one part of our equation that we're going to use. Then if we're trying to find side B, and we know that angle B is 65. So now we're just going to take this and solve for B.
Yikes.
So it basically sets up a proportion. So we need to cross multiply.
Wait, what? Wait, why can't we use our calculator to find the bottom?
I mean, you can, but it's...
Can I go in the draw? Can we do that? Can we do that?
All right.
Because that's how I'm going to do it.
Well, can I show you something first before we... So basically, you're going to get 6 times the sine of 65 is equal to B times the sine of 40. It's going to save you a step in your calculator if you put it in as 6 sine 45. Like, it'll do all of that at once for you.
Okay.
And then you're going to have less places to round, so that means in the end you're going to get more accurate answers.
Okay.
And then you're going to take that number, right, and then we got to get B by itself, so we're going to divide by the sine of 40.
40.
So then in your calculator, you're literally going to plug in and find 6 times the sine of 65 and then divide that by the sine of 40.
And then that gives you B.
Yep.
Six. Wait, should we be on radical or deg or rad?
Degrees, yeah.
I am I'm just dead.
Deg. Sounds like you're saying dead.
I'm deg inside.
So then,
Kinda rude.
what?
It's kinda rude.
How did you-
5.4378.
maybe one of my settings might be a little.
Okay. Yeah, so then final answer should be 8
Can
point,
you wait for a second so I can make sure I've done it right?
We're doing degree, right?
yes.
Sine. It's gonna be like, here's
Now that
the
we found side B, we have to do it again and find side C. So we're basically going to do the same kind of process.
Ooh, wait, do we have to have A there then?
Yeah, so we're going to use this part here again.
Hold on. Do we still have to have A in there or can we just do B and C? Because we didn't need C in that one, so do we need A in that one?
Well, I'm going to use A because we know that like we were given that information to start with, so we know it's
True.
correct.
So just use A instead of B.
Yeah, so I'm just going to use
We've
A
done
and
this
C.
before, But in a different, like, have we done something exactly like this before? Not exactly like this, but very much like this. Like, where you
Yeah.
do part of the problem and you go back to the other part of the problem.
Yeah, when we solved right triangles, we did a lot of this.
I feel like we've done this. That's probably why.
It's very similar to solving right triangles. We're just using a slightly different formula instead of Pythagorean theorem now. And then we're going to use C over sine 75 now because that's the angle for C.
C is 65.
C is 75.
Wait, I have white out.
Probably because I gave you some. So again, we're going to cross multiply. This time we'll get 6 sine 75 is equal to C sine 40. And then divide by the sine of 40. Divide by the sine of 40. And then you can plug it in the calculator just like this to get your value for C, which I'm going to write over here. So you can do 6 sine 75 divided by sine 40, which gives you 9.02.
I like this.
I figured you guys would. So for the sides, I would like you guys to always round to 2 decimal places. And angles, just to make it easier, round to the nearest whole number for angles when we find them. We're going to do an example in a minute on where we have to find an angle measure.
Can I guess? Oh.
Guess what? There's nothing left to guess. We solved everything.